So when you are combining functions, combined functions, that only means that you are going to add, subtract, multiply, or divide the two functions together. Combining them just means you're going to do one of those four things. You're going to add them, subtract them, multiply them, or divide them. So good news. If you can add, subtract, multiply, and divide, you can do this. And I believe in you. You should believe in yourself. Good, I'll take it. All right. So using these two functions, look, f of x and g of x. Are you seeing this here? F plus g. Literally, all you're going to do is take this one. So 2x squared plus 3x minus 1 plus the other one, x minus 4. That's really it. Now you're going to combine the like terms together. Again, if you can add and subtract, you're going to be just fine. So like terms, what's going to go together there? The 3x and x, good. So 2x squared plus 4x and then minus 5. Good. That's the answer. That's all. If you're like, that's it. Yep. That's it. No, not really. Now we're going to subtract them, f minus g. Now, subtraction does involve a negative sign, and negatives can be difficult, so just make sure you're careful. You're going to take the first one, so 2x squared plus 3x minus 1. Now, you need to give this a hug, because you have to subtract the whole thing. You have to subtract both of those terms, which just means you're going to have to distribute the negative sign. That's just going to negate everything in here, and I'm just going to erase it to fix it. It would be minus x and then what? Plus 4. Good. Everything's just going to be opposite. Which again, negatives can be difficult, so just, be careful with that. But it's just the opposite. And then you're going to put them together. So same thing. The 2x squared is not going to go into anything. 3x minus 1x, 2x, and then negative 1 plus 4 is 3. Now, when you're adding, it doesn't matter what order you add in. F plus G would be the same as G plus F. Do you get what I'm saying? Like, it won't make a difference. But when you subtract, it actually does matter. F minus G is going to be different from G minus F. Okay? So we're going to do G minus F this time. So make sure you start with this one. It'll be X minus 4. And then you're going to subtract all of the other functions. So all of F of X. And again, you're just going to have to distribute the negative sign. Everything is just going to be opposite. So minus 2x squared minus 3x plus 1. So they're all just opposite. I was kind of just erasing and fixing it. If you want to write it as a whole nother line, that's fine too. And then you'll just put the like terms together. Now, it doesn't matter what order you write them in, but is anyone else like the squared has to come first and then the x and then the number? Like, I'm very much like it has to be in that order. So negative 2x squared. And then what would come next? So negative 2x, good. And then we have a negative 4 plus 1, negative 3. What I'd like for you to do is compare these two answers and let me know what you notice. They're opposites. So F minus G and G minus F, you just negate them. So if you find this one, you can just like basically distribute a negative sign. That's going to give you the other one. All right, what does this mean? It's just a dot, but that means what? Multiply. All right, so we're going to take this whole thing times x minus 4. Now this is where you have a bunch of distributing, and it really doesn't matter what order you do this in. So I'll show you how my brain does it. If you do it in a different order, that's totally fine. I'm going to take the x, distribute it to all of that. And then I'm going to take the negative 4 and distribute it to all of that. So if we distribute x, that would be 2x cubed plus 3x squared minus x. And then if you distribute negative 4, negative 8x squared minus 12x plus 4. Some people write this like this. Like, did your algebra 2 teacher teach it to you like this, where you make like a, like, does anyone know what I'm talking about? Yeah. Like, and then you can do it that way. And then like you have everything in the boxes. So if you want to do that, that's fine too. That helps people stay organized. And so you get this big long string of information, and then we're just going to put the like terms together. So 2x cubed, let's see, minus 5x squared minus 13x plus 4. And it doesn't matter what order you multiply either. So f times g is the same as g times f. Those mean the same thing. And then the last one's dividing. F divided by g. So you're going to take this whole thing, the 2x squared plus 3x minus 1, divided by x minus 4. This is a synthetic division. No one groaned. That's awesome. What number goes in the little box? 4. 4 is your troublemaker. And then take your countdown numbers, 2, 3, negative 1. We're going to multiply, add until we get to the end. So bring down the 2. What's your next number that you're going to write? 8, good, add. Ooh, 11, 44. And so your remainder is 43. It's been a while since you did one that actually has a remainder. Like they usually come out to 0, like for the other problems that we were doing. So let's remember how to write this. We started with a squared. So when we divide, it's just going to be x. So 2x plus 11. Do you remember how to write the remainder? Because that was back from unit 3. Good. 43 over x minus 4. Good. Well remembered. That's all that combining functions is. We did add, subtract, multiply, and divide. So what I'm going to do is pause the video, and I want you to try these ones with your group. It is just practice on what we just did. It is add, subtract, multiply, and divide. That's all I'm asking you to do.
Oh, thank you.
All right, so I wrote up the first 3. When you do 7, you don't really need to do any work for 8. You can just negate all of those terms. Double check me as well, though, because I'm human and I can add wrong. Did you get the same thing as me? Okay, I do mess up negative signs as well, so we'll look after each other. All right, multiplying them. So we're going to take this one times this one. And again, it really doesn't matter what order you distribute all of this. I usually, I'll take the x and distribute everything, and then take the 1 and distribute to everything. So if we distribute x, negative x cubed plus 2x squared plus 4x. If you distribute 1, basically you're just recopying the thing, like nothing's going to change. And so you get this big long string of stuff, and then we're going to put the like terms together. So negative x cubed. Did you get plus x squared plus 6x plus 4? Confirmation. Okay, I'm hearing yeses. And then the last one, f divided by g. So you're going to take this whole thing divided by x plus 1. So who is your troublemaker that goes in the little box? Negative 1, good. Oh, whoops. I guess if I put an actual 1 there, that would be good. Negative 1. And so your countdown is negative 1, 2, 4. And we're going to multiply, add. So this will be positive 1, 3, negative 3, 1. All right, and so when you write your answer, we started with a squared, so we're going to start with just an x. So negative 1x plus 3. And then your remainder goes over the x plus 1. Everyone's feeling okay? I told you this lesson was quick and easy. All right, so that's combining functions. The other thing that we're going to do is composite functions. So we did add, subtract, multiply, divide. The other part of this is composite functions, a composition of functions. And it looks like this, f of g of x. The other way you can see it written, which I don't like as much, is like this, f of g of x. I don't like that because it looks like fog. Anyway, the only reason I bring it up is because this is how Delta Math writes it. Just write it this way. You have an outside function and an inside function. The outside function is f in this case. The inside function is g in this case. But don't get hung up on that, because what if we did g of f? Or what if we did h of q? Like the letter doesn't matter. This one's outside, that one's inside. And so here's how this works. The inside function is plugged into the outside function. And so the way that that relates to the telephone game is this. I'm going to explain this while you're writing it down. Each of you represents a function. The sentence that I gave you is the input. Now, when we do a math problem, the input is going to be like a number, right? But I gave you an input and you changed it. You as a function changed it. Are you following me here? And then you passed it on to the next function. And then they changed it. And then they passed it on to the next function. So when you go to do a problem like this, here's our two functions. You're going to start with the inside one and you're going to do g of 4. Kind of ignore everything else. We're going to do g of 4. How would you do g of 4? Take 4. You're the only one that said anything. So you're going to take 4 and do what with it, guys? Plug it in. To which one? G. Plug it in for x to function g. All right. So look it. We're going to plug in 4 right here. You with me? 2 times 4, 8 plus 1, 9. It's like the sentence I gave you. It was 4. You changed it and got 9. Then you take 9 and you pass it along to the outside function. That's like you took the sentence, you changed it, and you passed it along to the next person. So then you're going to take 9 and plug it into function f. It is exactly like the telephone game. Just think about the telephone game. It works the same way. So when you plug in 9, 9 squared, 81 minus 7, is that 74? Okay. Brain did something weird there. All right, so for this one, you're going to start with the inside function, f of -6. Kind of forget the rest of this. You're going to take -6, plug it into function f, and it's going to change. -6 squared. Positive 36 minus 7, 29. And you're going to take that new number, that 29, and pass it along to the outside function. So it's g of 29. Make sure you write this middle step for me, because then I can do partial credit. Like if your answer's wrong, I can't help you unless you showed me what you were thinking there. So then you take 29, plug it into g. 2 times 29. I would do 2 times 30 and then just back it up a little bit. That's how my brain would do that. So good, 58 and then plus 1, 59. Now this is f of -2. That's fine. You're just going to use the same function twice. That would be like telephone game, except you passed it along to yourself. Okay, which hopefully you would get it right if that was the case. But anyway, f of -2. So we're going to plug -2 in. -2 squared. 4 minus 7, -3. And you're going to take that -3 and plug it back into function f again. So if you take -3 and plug it in, oh, you said the answer already. -3 squared would be 9 minus 7 is 2. It is just like the telephone game. This is the same thing, but we're going to use a graph. Now, look, you're going to have to watch me point to it because I don't have a better explanation than look, there it is. Okay, because you're just looking at a graph. So for this one, start with the inside, g of -1. This one's g. Do you see that? You're looking for a point, -1 something. It's right here. And I'm sorry, I don't have a better explanation than it's that point right there. Do you see -1? 1. Do you see how it's -1 comma 1? Yeah. All right, so 1 is what gets passed along to the outside function. It was -1 comma 1. 1 is what we pass along. Then f of 1. So you're going to come over here to function f, and you're looking for a point 1 comma something. That something is going to be your answer. -2. And I'm sorry, I don't have a better explanation than, hey guys, look, it's that point right there. 1, -2. So -2 is your answer. If you were like, hey, I didn't quite get that. Good news, we're going to do 2 more of them. Which function do you start with here? F or G? G. Start with G, do G of 0. What is G of 0? 0. So then you're going to do F of 0. What is F of 0? -1. Good. Which function do you start with on this one? F. Good. Do F of -3. What is F of -3? Just find that point. 2. You're going to pass that along. G of 2 is 4. So you just have to be able to read a graph. Yeah, I told you it was. Oh, he's writing like the official, like you're just being particular about it. You can write the whole thing if you want. All right, now these ones you're not actually plugging in a number. You're just going to leave the variable in there. And we're going to do this both ways. Find f of g and g of f for each of the following. So now you are going to have to label them this time because we're going to do both. So for f of g, g gets plugged into f. Maybe watch me point to this. You're going to take all of g, this entire thing, and plug it in over here. Now, if there were two places there was an x, you'd have to plug it into both of them. But it's a replacement. It's like the telephone game. You took out a word, you replaced it with a new word. We're going to take out x and replace it with x minus 7. So it's going to be 2x minus 7 squared minus 5. It's a replacement, just like telephone game. Now you have the slightly tedious job of working that out, unfortunately. But you guys did well on this on that last test, so I believe in you. When it's x minus 7 squared, that means you have to write it twice. Good, thank you. And so that 2 is going to wait patiently. This is FOIL, first, outside, inside, last. So x times x, good. Minus 7x and minus 7x will be minus, perfect. See, I believe in you. Negative 7 times negative 7, 49. What unit did we do that in? 3? That was unit 3 we did that. Distribute the 2. That's 2x squared minus 28x. All right, when I do 40 times 2, I do 50 times 2 and then back it up. So 50 times 2 would be 100. So it'd be 98 minus 5 is 93. So that was a bit of distributing, but you know what? You're going to be okay. Now this time, and let me erase my arrow here and just watch me point to this. This time f gets plugged into g. So this entire thing is getting plugged in over here. I'm going to remove x and replace it with all of that. So it's going to be 2x squared minus 5 minus 7. Now that is a much easier problem. And typically they go that way. Like one way is easier than the other way. You with me back there, Renee? Is that your phone? If it is, can you put it on? Oh, no, okay. Sorry, I saw you looking at something on the side of your desk. All right, there's only one step for this one. Negative 5 and negative 7 will be negative 12. And again, usually it goes that way. Like one way, there's like a lot of steps, and the other way, there's not really too much to do. We're just going to try that a bunch more times. We're going to find f of g and g of f. You're going to be okay. No, each problem starts with 2 new functions. So for 14, we're using these 2. And for 15, we're using these 2. Like each one has its own new functions. All right, which function gets plugged into which here? G gets plugged into f. Good. This entire thing gets plugged in for x over there. So you're going to remove x and replace it with that. Yeah, now what's going to happen with that? Yeah, good. The square root and the squared are going to cancel. And so you actually just get x plus 3. And you can write it twice if you want, but like multiplying them together is just going to cancel. Because that's what squared means. That's like the definition of squared. And that's what we did on the other problem. It's just this one had a square root, so we just canceled them. So this one, f gets plugged into g. So this is getting plugged in over here. So we're going to remove x and replace it with x squared. So this is what you end up with. You can't cancel that. The only reason we were able to cancel this one is because do you see how it's a square root of the whole thing? And we squared the whole thing? Is the 3 squared? No. If it was this, do you see what I'm saying? The whole thing, then we could cancel them. But this, you cannot do anything to. So just hands off, that's your answer. I'll be really honest. The thing that people miss the most on these kinds of questions is they mess with them when you should do nothing. So hands off most of the time. All right, f of g, g of f. And I'm sorry, but please make sure you write those every time because one is one way and one is the other. So like you do have to write that. I'm sorry, kind of, but not really. Like you'll be okay. So g gets plugged into f. That means this whole thing gets plugged in over here. This whole entire thing, 1/3 x squared gets plugged in over here. So square root of 1/3 x squared minus 8. And what are we going to do to that? Nothing. Hands off. For the other way around, f gets plugged into g. So this entire thing gets plugged in for x over here. You're going to remove x, like telephone game. You removed a word, replace it with a new word. You're going to remove x, replace it with all of this. So 1/3 square root x minus 8 squared. What can we do with that one? You can cancel this one because do you see how it's square root of the whole thing? So you get 1/3 times x minus 8, and then you would just distribute the 1/3. So 1/3 x minus 8/3. Hanging in there, guys? No one's asking me anything, so I'm going to assume you're okay. Again, you have to write this. That's not optional because one is one way and one is the other. So g gets plugged into f. What is that going to look like? If I take all of this, plug it in over here. 1/x plus 6. Can I do anything to that? No. All right, plugging f into g. This whole thing is going to get plugged in over here for x. So that would be what? Plus 6. Good. Can I do anything to that? Do you see how these are different? Who's the troublemaker for this one? -6. Who's the troublemaker for this one? What makes that denominator 0? 0, right? Well, that's what the lesson's on the next time, so just be aware. All right, g is getting plugged into f. That means this whole thing gets plugged in for x over there. So that's going to be 1 over what? Absolute value. Good. You can't do anything to that. This is in an absolute value. That is not. Don't add them together and get 5. That's the most common. I would say like half the class does it. Don't do that. Are you guys like just done and ahead of me? Oh, okay. All right, for this one, f is getting plugged into g. So that means this whole thing gets plugged in over here. So you're going to have a gigantic absolute value with what inside of it? 1/x plus 2 plus 3. What can you do to that? Nothing. And then I like these ones. Just as like a puzzle, you're trying to do it backwards. You're going to come up with two functions, f and g. It's like this is the answer. I'm asking you for the question. You need to separate it apart. We want g to be the inside. So g is like the guts of the problem. And then f to be the outside function. Any thoughts? And I think it's easier to do g first, like the inside part, and then decide what the outside part is. You need the two functions so that if you did f of g, this would be your answer. What do you think for g? You want to throw something out there? Anybody? I mean, this is what the problem is. So it's going to have to be something that's there. Close. There we go. 2x minus 9. Wake up, guys. It's like the problem. Now, what would the outside function have to be? 1 over x. Oh my goodness, that was like pulling teeth, but I got you there. This one should go better. F and g. You want g to be the insides, like the guts of it. So 5x plus 7, perfect. And then what's the function you were plugging that into to get this as a result? Perfect. Nice job.